Hello guys and welcome back to another video tutorial series on searching algorithms. And today we're gonna discuss on another important and most popular technical interview question, and that is we have to check that within this array whether there exists any subarray with the sum as 0 or not. What it means is like we know that an array can be divided into multiple subarrays. For example, over here we can have 3, 3 and 4, 3, 4 minus 7. In this way, we can have multiple number of subarray. So we need to calculate that whether there exists a subarray whose sum is equal to 0 or not. So over here you can see the value of this corresponding subarray, which comprises of three numbers like 3, 4 and minus 7 is equal to 0. So we need to calculate that whether in this array that is given to us, whether there exists at least one subarray whose sum is equal to 0. So this is basically our problem statement. So before going into the solution of this program, I would like to tell you that in the description below, I have given the list of all the interview questions that you need to prepare for any technical interview. So go and check that in the description below. So let's move to the solution of this problem. So over here also, to solve this problem, I will be giving two solutions. One is the brute force approach and second is the optimal solution. So let's first understand the brute force approach using our whiteboard session. So the brute force approach to solve this problem is quite easy actually. So over here you can see that our approach is we need to first calculate the total number of subarray that are possible from this array. And after that we need to calculate the sum of those corresponding subarray. And if the sum of that array is equal to 0, then we will return that there exists an subarray with the sum as 0. So over here in this array you can easily see that we can easily create multiple subarray using our general for loop. So what we'll do is like we will write two for loop to create all the subarray over here. So let's start with the brute force approach of solving this problem. So what we are doing basically over here is like we will be writing two for loop. One starting from the first index over here and second starting from the I plus 1 index over here. And we will keep on iterating these two variables till the end of this array. And once we reach the end of this array, we will get the total number of subarray that can be generated from this array. So let's first write down the function to create all the subarray out of this array. So let's name this function as calculate zero sum subarray. And over here we will be passing the entire array that is provided to us. Now the first step that we have to do using our brute force approach is like we have to compute the total number of subarray that are possible to generate from the array. So over here we will be writing two for loop to generate the total number of subarray that is possible. So over here we will start our for loop from I equal to 0 and another for loop from j equal to I plus 1. So over here you can see we have constructed two for loop, one starting from I equal to 0 and another starting from I plus 1. So if you want, you can also start this for loop from j equal to I. Then at that time you can construct this single element as one of the subarray. But since we are calculating some of the digits, we can ignore this case of j equal to I. So I'm constructing this array with at least two elements present over here. So over here what we have to do, we have to create one more function that will calculate the sum of this subarray. So we will write a function called as sum and we will pass the corresponding array and the value of the index over here. And we will check that if the value of this corresponding subarray is equal to 0, we will return true from here. Means yes, there exists a subarray whose sum is equal to 0. Otherwise at the end of this for loop we will return false. Means we didn't encounter any subarray whose sum is equal to 0. Now let's write down the function to calculate the sum of this subarray. So over here what we'll do is like we have to write a simple function that will return the value of the sum. So over here we will be taking the corresponding subarray over here and the value of the I and j. And we will write a function to calculate the total sum over here. So it's quite simple, it's just like calculating the sum of an array starting from this index to the corresponding j index. So over here you can see that we have written a function that will calculate the sum of this subarray. So here I'm iterating an array from c equal to I till c equal to j. Means I'm just calculating the corresponding value of this subarray and returning value over here. And so if the value of this subarray is equal to 0 means this satisfies our condition, and thus we will return true, which means that yes, we got a subarray on this array which have the value as 0 and which satisfy our condition and our problem statement. So this is basically a very general and simple approach to solve this problem, because if you see the complexity of this program, it is quite high. So over here you can see we are using two for loop to generate all the subarray that are possible over here. So to calculate the total number of subarray over here, we are using order of n square. Moreover, to calculate the sum over here, we are again using the complexity of order of n. So the runtime complexity of this entire function becomes order of n cube, which is pretty much high from a programming perspective. So to give the possible best solution to this problem, we have to write a simple logic whose runtime complexity is much more lower than order of n cube. So in our next solution, where we will be solving this problem using our optimized solution, we will be solving the same problem using a special algorithm which have a time complexity of order of n, which is quite less than that of order of n cube. So let's see what different approach that we will be taking to decrease the complexity of this program from order of n cube to order of n. So let's jump to the solution of this program to solve this problem in the most optimized way. Now since we have understood that how we can solve this problem using our brute force approach, let's now optimize the solution. So let's start with optimizing the solution and let's find out how we can solve this problem in the most optimized way. So solving this problem in the optimized way is actually quite simple if we understand some basic fundamentals and if we observe this array very carefully. So before solving this problem, we have to make certain observation out of this array so that it will be easy for us to understand that how we are planning to solve this problem. So over here you can see that at the starting point over here, sum of the array is equal to 0. So what we are doing is like we are iterating this array one item at a time, and we are sequentially adding one value at a time. So over here you can see that the very beginning over here you can see that the value of the sum is equal to 0. Once we start iterating over this array, we can see for the first time we encountered the value 3. So over here the value of the sum is 3. So on our next iteration we got the digit as 4. And once we add the value 4 to our corresponding sum, it becomes 7. So over here 3 plus 4 becomes 7. Now once we encounter the next value, that is minus 7, over here you can see our corresponding sum 0 again. So this is actually the key fact by which we are planning to solve the problem. So over here you can see that we have started our programming where the value of the sum was 0, and at the end of minus 7 our sum again went to 0. Means the value of this subarray is 0 because there is no impact on the variable sum after adding this 3 consecutive number. So since the value of the sum is 0 before and after adding all these items in this subarray, we can easily conclude that the sum of this subarray, that is 3, 4 and minus 7, is equal to 0. And thus we can conclude that yes, there exists a subarray within this array whose sum is equal to 0. So I think the approach is quite simple and quite tricky. And hopefully you also got the approach of solving the problem. So what we are doing is like this: at the very beginning, before iterating the array, we are initializing the value of sum to 0. And once we are iterating one item at a time, we are adding the number over there. So now value of sum is equal to 3. And once we are getting the value over here, we are actually storing this in a bucket, that is a hash set. So what we are doing is like at the very beginning, when our cursor is at minus 1, we are storing the value 0 in our hash set. So means this is the starting point of our iteration. Means we are initializing our hash set with the value 0. Now we are iterating one item at a time. So over here for I equal to 0, the value of the sum is 3. So we are checking that whether the value 3 exists in our hash set or not, which means that whether we have already encountered this value before or not. So since we have not encountered this value before, means we have not encountered this sum before, we are just adding that value within our hash set. Then we are again moving to I equal to 1, and over here our sum becomes 7. So we are again checking that whether the sum 7 exists in our hash set or not. So our hash set does not contain the value 7. So here we are again pushing the value 7 into our hash set. Means we have not encountered 7 before. Now on I equal to 2, that is on our third iteration, we get the value as minus 7 and thus our sum becomes 0. And over here we are checking that whether the value 0 exists in our hash set or not. And yes, we have a value 0 present over here. Means we have already encountered a 0 initially, that is the starting point. And after adding all these values over here, there is no impact on the value of the sum. Means whatever the element that we have encountered over here sums up to 0. So I hope the solution is quite clear and simple. Let's understand the solution in depth using our visual display board. So our problem statement says that within this given array, we need to find out one subarray which have a total summation value as 0. And we have to tell that whether such subarray with sum 0 exists within our array or not. So to solve this problem in the optimized way, what we are doing, we are using an external data structure that is a hash set. So at the very beginning of our iteration, we are initializing the hash set with the value 0, that is our sum value. And now we will start our iteration from I equal to 0, that is the first index over here. So over here the value that we have received is 3 and thus our sum is 3. And we are checking that whether the sum 3 present in our hash set or not. And since it doesn't exist on the hash set, we are pushing the value over there. Now we are moving to our second iteration, that is item number 2. So the item number 2 is 4 and the total summation of the previous item with this current item is total 7. So again we are checking that whether the value 7 exists in our hash set or not. And since it doesn't exist over there, we are pushing it into our hash set. Now on the third iteration, we got the value minus 7 and the total summation of this corresponding subarray is 0. And we are checking that whether this value 0 exists in our hash set or not. And here we see that this value 0 already exists in our hash set. Means we got a subarray whose total summation value is 0. And thus we conclude that yes, there exists a subarray with sum as 0. So over here if you see that the total complexity to achieve this program in the most optimized way is order of n. And since we are using an additional hash set to store the sum value, over there we are increasing the space complexity to order of n. So over here you can see that with the help of a simple auxiliary memory and by increasing the space complexity to order of n, we have decreased the time complexity from order of n cube to order of n. So I hope the solution of this problem is quite clear and easy to understand. So let's write the Java program to implement this idea. So hopefully you have understood the way we are planning to solve this problem in the most optimized way. If not, please feel free to rewind the video from beginning to understand the concept. So let's start with the Java implementation of this above problem in the most optimized way. But before that, I would request you that if you like this approach of solving this problem, please like the video and also share the video, and don't forget to subscribe to my channel. And if you're new to this channel, don't forget to hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start with the implementation of the above solution in the most optimized way. So let's name the function as 0 sum subarray. And over here also we will be passing this entire array as our parameter. So the first thing that we have to do is we have to initialize an hash set over here to store the sum of the values. And as we have seen in our solution that for the first time we are initializing the hash set with the sum as 0. Now what we have to do is we have to iterate over this entire array and keep on adding the sum of the values. So what we will do, we will initialize a variable called as sum which is equal to 0. And we will iterate over this array. So as we are iterating over the array, we will keep on adding the values in our sum variable. And we will check that whether this value sum exists in our hash set or not. So in this case, for the first time over here, we have created an empty hash set over here. And then we have added a value 0 into it. So right now our hash set is occupied with only one value, and that is 0. So over here we are adding the first item into our variable called as sum, and we are checking that whether this value sum, which is currently equal to 3, exists in our hash set or not. So we'll check that if the hash set contains this value or not. So if the value, that is the sum, exists in the hash set, then what we'll do, we will return true from here. Means we have encountered a subarray with the sum as true. And if not, we will keep on adding the sum into our hash set. And we will keep on doing this same process again and again until we reach the end of our array, that is the size of the array. And at the end we will return as false, which means the array doesn't contain any subarray with the sum value as 0. So I think the solution of this problem is quite simple and easy to understand. So over here you can see that the complexity of this problem is order of n, and the space complexity over here is also order of n. So you can easily see that using a small hash set into our problem, we have optimized our solution from order of n cube to order of n. So this is actually a good way of solving this problem. So hopefully you have understand the solution to this problem. If not, please let me know in the comment section below. And don't think about the code. I will also share the code in the description below. Feel free to download the code and understand the problem in depth so that you can easily solve this problem during your technical interview. And I will definitely say that this is one of the most popular interview question for any technical interview. And there are a lot of varieties of questions that can be asked based on this solution. And in my next video series, I will be solving those various type of problems. So let's move to the next problem of our searching algorithm series. See you on our next video. But before that, don't forget to like and share this video, and don't forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on the next video. Thank you.